Hi everyone, how you doing? So this is the last one before the coffee break, by the way, so hang in there. So I'm Thorsten Lorenz. I work for NodeSource, and I've been working with Node.js quite a bit. And lately I do this remotely, so this would be a typical office of mine. Also, if you want to follow me on Twitter, do that right now, th.lorenz. Also on GitHub, th.lorenz. So today I will talk about a feature that was added quite recently to Node.js, and it's called Async Hooks. So why am I talking about Async Hooks? Well, if you're running your Node application, under the hood there are like hundreds of concurrent operations going on at the same time. And if you're serious, like if you're using Node in production, at some point you want to see what's going on under the hood, right? You want to inspect or debug these asynchronous operations that are going on. And originally that wasn't really possible at all. And then there were some early solutions, and most of those involved patching Node.js core modules or maybe patching the event emitter. But none of them were really that great. They gave us some insight, but most of them actually also had a performance overhead. So you had a choice of you're running your application as fast as you could, or you're running it and you get some insight, but now it doesn't run as fast anymore. So some thought we can do better. And the result of that endeavor are async hooks. These are the voyages of the Node.js core team. Its 4-year mission to explore strange new APIs, to seek out new ways of capturing asynchronous operations, to boldly propose pull requests that no one had proposed before. In this talk, I will first introduce you to the history of async hooks. How did we get to where we are now? Then I will show you the lower level API of async hooks that allows you to capture any asynchronous operation that's going on inside of your process. And finally, I will show you a higher level API that then allows you to put those operations in context with what you are doing in your application. So async hooks to me, by the way, thank you. So async hooks to me is a perfect solution to the problem that we just stated. It is a generic solution to capture any asynchronous resource that's kind of taking place in your process. It has a minimal performance overhead, especially if you're not using it, because it has none. And it has a powerful and flexible API. But we didn't get that right away. So let's start in August 2013, when Forrest Novell proposed the continuation local storage core module. And that would have allowed basically to propagate information attached to requests, so you can identify the requests kind of on the different stages. But that approach was deemed too specific. And at that point, Trevor Norris actually started to seek for a more generic API. And just about a month later, in September, he introduced the async listener, and there was a pull request that was merged. And the idea of async listener was it should have zero overhead when it's not in use, and it provided a highly flexible API. And in conjunction with that pull request, there was an async wrap class that was introduced. And that was basically as a central point to capture any asynchronous operation that's going on. And that is really important because that async wrap class is still there today. However, about a year later, it was removed again, because there were certain problems that they couldn't figure out that affected all of core. So it had to go. But right before that, they introduced hooks to that async wrap class I mentioned, along with some JavaScript bindings. And the idea was then that people could experiment with this. It was kind of a secret API, so people could experiment and hopefully find a better solution. And a little more than another year later, we see the first async hooks commit by Trevor. And in September 2016, the async hooks PR landed, and later on it was cleaned up, and some tests were added. And in May 2017, the async hooks pull request was merged, and then released with Node 8. And as you can see here, there are a bunch of changes, right? There are 5,300 lines, or like insertions. Half of them are tests, and that's really important because these changes are not just isolated to like one module. These changes are all over core, right? So we really have to make sure this works. And there were people that actually helped, like Andreas Madsen, for instance. Early on, he wrote a visualizing tool where we could basically give it data that was captured by async hooks and kind of look, does it even make sense? And later on, I joined and added a bunch of tests to make sure this works as expected. And we actually caught some bugs with those and fixed them and so on. So what are async hooks, right? Well, basically, as I said, there's this async wrap class, right? And so any asynchronous resource that gets created under the hood actually creates an async wrap class. So for instance, if you do fs.open, right? Under the hood, there's something that happens in C++ land, and that allows particularly Node to track, right? Because anything that inherits from async wrap class can then be tracked because it's considered an asynchronous resource. So let's look at what that looks like. Here we have the async wrap class and its inheritors, right? So we have some like the connection, we have HTTP2 session, you can probably tell what that's for, and so on. There are also some more generic ones, handle wrap, for instance, and rec wrap. So let's look at those in a little more detail. So the handle wrap, for instance, we haven't inherited the FSU event wrap, which is basically created if you're watching a file. And there's a timer wrap, which is created when you create a timer, and so on. Then we have the rec wrap, so we have the FS rec wrap, which is pretty much any other file system operation that you could do. Get address info rec wrap is created, for instance, when you do a DNS lookup, and so on. And here we have a longer inheritance chain. So the pipe wrap, even though it has multiple levels of inheritance, it still inherits from async wrap, still an asynchronous resource. And when is one created? Well, for instance, if you have a network connection, that pipe wrap is created under the hood, as well as if you spawn a child process, right? In order for that child process to communicate back to the parent process, a pipe wrap is created. Here we have these providers. So basically, these provider names map pretty much back to the class names we just looked at, and they're used in core to identify the asynchronous resource, but also we can use them with the APIs, which we'll look at later, to identify which part of Node are we actually looking at, like what part of Node is this asynchronous resource actually for. So in summary, pretty much anything that's going on in your Node.js process, right, is tracked with this, because hopefully you're not doing anything synchronous in your Node.js process once the server is running, because you shouldn't. So anything else is asynchronous, so you can track it. And how do you track it? Well, Async Hooks provides an API for that. And in this talk, we'll just look at one part of the API. I deem it the most important. But there is also an embedder API that you might look at if you're interested. But what we'll focus on are just the lifetime events. So there are 4 lifetime events: init, before, after, and destroy. Init and destroy are only called once because asynchronous resource is only created once and destroyed once. Before and after could be called multiple times. So let's look at them a little closer. So init is called when a class is constructed that has a potential of emitting asynchronous events. So that basically means that an asynchronous resource is created. And look at the parameters a little bit closer here. We have the async ID, which is basically the identifier of that instance of the asynchronous resource. So that async ID will never be the same. I talked to Trevor. He told me we could, multiple light years or whatever, we could run our process and we wouldn't run out of numbers here. The type is the provider type that we looked at earlier, right? That tells you, am I dealing with a file system resource? Am I dealing with a network resource? Whatever. The trigger async ID has to do with the execution context in which the asynchronous resource was created. Like basically which asynchronous resource was responsible for creating this one. And then the resource is basically different every time for each type. And that's really important because this one has a bunch of information attached to it. It's a JavaScript object that you can basically inspect and walk, and you can gain a lot of information about what you're dealing with. So how would you use that API? Well, you create the init method here. You give it these parameters, and then in this case we're just logging them out. Now we'll look at why I'm using this print method in a second. And then you create the hook. You pass the init method. You enable the hook, and now when you set a timeout, you will see the init. So let's do that. All right, so let's make it a little bigger. So basically what you see here, we get 2 things. We get a timeout and we get a timer wrap. And some of you may think, why do I get two things? That was one timeout, right? Well, that's the first indicator where we see that what you're doing is not necessarily exactly what's happening under the hood. So there's kind of an impedance mismatch, right? So, but we'll get to later how we can work around that, because as we can see, it's a lot of information, right? So, but one cool thing, for instance, we can see here that the timeout was 10, and we can get a bunch of other information. So let's look at another example. Oh, one thing I want to show before. If you happen to subscribe after, right, so here we're setting the timeout, and then we enable the hooks, you will see nothing. So nothing, because basically you subscribed after the resource was created, and so you didn't see anything. So here we have a similar example. I just hit all this initialization code in this module, but then I enable the hook. We make a server listen, and let's see what we get there. As you can see, we got a TCP wrap, and we got a tick objects. Again, we did one thing, but we got two impedance mismatches there. But the cool thing is, of that tick object, of the args, we see the server hanging, right? So we can even see our server. We can see the callbacks. We can see the state. We can even see the connection key. Pretty powerful stuff. And now I'm going to get real quick to why I use this print method. Well, the problem is that console log, even though it's not considered async, is actually, the first time you console log, there are two asynchronous resources created, and then every time you log after that, there's another one created. So what would happen if you log in the init method is we would cause another init to happen, right? And another init, and we would end up in this endless loop. And I'm just mentioning that here because most of you, like me, will probably, when you play with this API, that's the first thing. Oh, I'm just going to console log something, right? Well, you can't do that here. So here we have an example basically where I console log first to get these first two things out of the way, but then I log after, and we'll see that we'll still get we get something created. So let me run that example. So what we get is a tick object, and you can see that the write stream is hanging off that. So that's most likely the standard out, right? So that happens every time you log. So you can't use console log, unfortunately. But what you have to do is you have to use a little print method. So the main important part is that I'm using process_raw debug. And that doesn't cause anything to be created. I'm also using util inspect here just to make it look nice, right? But just keep that in mind when you play with async hooks to use process_raw debug. So now let's look at the other lifetime events before and after. I'm just going to run through real quick through this. Basically, before is called right before your callback is called, right? So let's say you have a set timeout right before your on timeout is invoked. The before fires, and then it is invoked, and then the after fires. That's pretty much all there is to it. And you just pass these in. They only take an ID, but the ID is basically the same one that you got in your init, right? So that's how you can identify the resources. So if I run this, it would look like that. So we have the timeout and timer rep created, then the befores fire of each. You can see the order is kind of like timer rep first, timeout last, then your callback fires, and then the order of the afters is the other way around. So then we have the destroy. Similar, it's very easy. You just get an ID, and that's basically fired when the resource is destroyed. So if we take the timer example here, right, the befores and afters fire, and then since now your timer expired, you don't need that anymore, so now it's destroyed, and then you see that here. And now we're going to look a little bit into detail, how that is actually implemented. I mentioned that this is all over core, right? So basically, I'm going to race through this because I don't want to run out of time. But when you create a timer, right, the timer rep is used in timer.js right here. And then basically what happens is when you start the timer, this is actually delegated to libuv. And then you pass libuv this onTimeout method, right? And when that onTimeout method happens, right, when it gets called, you first resolve the timer wrap. And now we already have our async wrap, right? And now a bunch of other things happen. In the end, it makes a callback on that wrap, keeps collecting more stuff, and we make another callback. And then here we collect kind of the async hook context, right? And then we call internal make callback. And that's where all the magic happens. So basically, the internal callback scope is created, and that's when before fires. And we'll look at why that is in a second. Then your actual callback is called, the timeout. And then the scope is closed, and that's when after fires. And this is how this works. So the constructor of internal callback scope has an limit in there. And the close of the callback scope has and after in there. It's not always the same way. So, I mean, this is just an example. Sometimes also from JavaScript, events are omitted. But this is kind of a general, give you an idea how this would work. Now we're going to look at a cool example. So I wrote this awesome server. It has basically one route, /end, and that makes it to shut down. And all the other routes, it just says, OK, it's fine. So what I basically did, I launched that server. I made it collect async information. And then I fired 3 client requests to this. So this is a demo we're going to do. So 3 client requests. And the last one basically was /end to shut down the server. So what we see here, we see already a TCP wrap here, right? And that's because the server just started to listen. And if you click on that, we can even get some more information here. We can even see, it's a little hard to see, but we can see server listen, and we can even find our code that caused that to happen. So now I'm going to play this. This is just a little more than half a second. And I'm going to go along as it runs. So server continues to listen, first client request, second client request, and the last client request. So as you can see, this is a lot of stuff, right? So first of all, this one here, these 3 things, that's because the console log happened, right? I said listening on whatever port. So that's what happened here. And then the first client request came in, and we see that the HTTP parser was created, and that actually lives for the rest of the application, doesn't create it all the time. We see a bunch of tick objects, crazy stuff, right? All this data, like we have to actually look at what it is. But basically, this is like the server responding to the client and so on. So I'm just showing you this. Like I tried to really hard to make this readable, and you know, I colored this and all this stuff. It's still like a lot of information, right? So basically, what this means is, if you are like consuming async hooks, like with the API that it provides, you're actually going to have some overload of information. But that's good because, I mean, that's the idea, right? The API is supposed to be really flexible and supposed to give you anything that you could possibly need, right? But if you just use it as is, like, it may be too much. So what I believe is, you know, like, in order to use async hooks directly, you actually need to understand Node, right? You need to understand, like, what do these tick objects mean, and so on. So therefore, I don't think that many people will use this low-level API directly. Instead, very advanced users will use it maybe, and most likely to build higher-level APIs on top of it. So what we first can do, we can try to make the data you know, represented in a way that it makes sense to you, right? Like what were you doing in your app? We can kind of communicate that a little better. And then also, you know, like maybe you're only interested in file system operations. You don't care about all the other stuff. So then we only should show, you know, collect information about file system operations and not all of it. Because if you just look at your, you know, this would be the event loop, right? And all the ants running around, these other activities. If you just look at that, it's very confusing. Like you can't really make sense of it. So first of all, we can do, we can identify lower-level operations. So what do I mean by lower-level operations? Well, so basically, if you do an FS read file, right, there's a bunch of operations that happen under the hood for you. Stat, open, read, and close. And those I consider lower-level operations. And what we first can do, but they think they're all FS rec wraps, right? So this one also FS rec wrap. But it's not the same thing. This one could be stat, for instance, right? And this one also FS rec wrap. So what we can do, we can try to maybe look at the stack trace that we get in the init method, or maybe look at the resource and try to figure out, like, what is it? Is it a stat? Is it an open, right? So that's the first thing we can do. And then we can expose it in a way, like where, OK, there was an FS open. So you don't look at some data which has an FS rec wrap in it, but it tells you what it is. And then if you do that, then we may be able to group them together too, right? We know that it was an FS read file. We can maybe figure out that they're related and show them to you as an FS read file instead of you know, these separate operations. And then, as I said, we can then focus on only one part of the system. Like, let's only focus on the network. Let's only collect information about that. And then also, I believe there are going to be 2 modes of tracking. So basically, if you're thinking about how you're watching your memory or your CPU, like, you know, you're watching your memory the whole time, but you're not taking heap snapshots all the time, right? So you're watching, oh, my memory's going up, and that doesn't take too much resources to just collect the, you know, the number, how high is my memory. But then when you run into a problem and your memory is spiking, that's when you take a heap snapshot, because you know that there's going to be a performance overhead, but you take that into account because it's worth it, right? Because you want that information. So it's kind of the same with asynchronous resources. You might watch the file system operations, and you just collect a count, how many am I doing? And then once you find an outlier, that's when you go to mode 2 and you say, okay, now it also trace file system operations, but in this case, maybe take stack traces, maybe walk the resource, get more information about what's going on there because I need to figure out why I have so many. So that has lots of overhead, right? But you're willing to take that because you want that info. And since at NodeSource we're trying to make this all easy for everyone, I already started working on this a little bit. So this is the file system collector example. So what this does is it uses async hooks under the hood, and you just instantiate it like this, and you pass some ops over here, and then you enable it. And now your system is running, file system operations are happening. When you want to get the data out, you just disable it. Then you clean all the resources. This part is important. So basically, if you're using async hooks and you're holding on to an activity to get the data, when the destroy is called for that activity, you need to let go of everything. Otherwise, the garbage collector can't collect the activity properly. So what I'm doing here is I'm saying, okay, some of them might still be in flight, though. Some of them might not have been destroyed. So I still want to clean them up. So I do that. And then here we process stacks. And then here's the same for the network. Looks very similar, right? And that's the whole idea, that the APIs are very easy to use and similar. And then, as I said, then we can take that data and maybe we can process it further to make it even more useful to you. So here we have the file system processor. And so we give it the activities that the collector collected, and then we give it some options, like in this case, including activities. And then it's demo time. So I'm going to show you what we can do with this. So I have a few demos here. The first one we're going to do is just basically a thing that reads a bunch of files. It just goes through the directory and just reads a bunch of files. And before it does it, it enables the file system activity collector over here. And then it reads all the files here in a timeout just to make it more fun. And when it's done, basically, it does what I just showed. It collects the data. And then it writes two files. First, it writes the file, kind of the raw data collected, and then it processes them and writes them again as operations, which is the process version. So if you just run that, all right, so we got two files. So let's get that one in. So here we kind of see all these activities that we collected. So we have, and most of them are fsrecwrap because we just read files, right? So we can, it's kind of cool, it's a lot of data, but it's still not really consumable, right? So we can do a little better. If we look at the operations. So here we can actually see, okay, so there was an operation, it was a read file. And it took this long, like it was alive 19 milliseconds, and it was created here, and so on. And there was an open operation, and then we can see that there was a start operation, and there was a read operation, and so on, right? If I find it there. So that's already more useful. And to make it, this is not a dashboard that I'm going to show, but it kind of gives you an idea how you could visualize this. So this is a timeline up there, and every one of these rectangles is basically an operation. So you can click on those. We can also just click here and kind of see where we actually did start the file read, and we can also see where the callback was registered. We can get all this information I just showed in the JSON file. It's just basically rendered here a little nicer. So we can see it's a read file. We can see it over here. And we can even get some information about the file we read. We can even sometimes look at what we were reading. Yeah, here we go, right? You may not want to include that, obviously, for security reasons. But sometimes it's useful, and so on, right? So now another example, which is basically the same thing, but this time we launched the server, and it just responds to a client request. So we have a server and a client, and we can basically track the server, or we can track the client, right? So I'm going to show, actually, I'm going to run the server with Installed. So I don't know if you heard of Installed. It's the Node.js drop-in replacement that we created at NodeSource, which adds a bunch more diagnostics, security, and so on. And it's 100% compatible with a Node. So this should work with Installed as well. So running this with Installed. So let me do that. Install it. Okay. So now I ran the server, and the client did 2 requests, and now we can look at what the server looks like. So server starts listening here, and it listens obviously as long as it's alive. And then we have the client request coming in, and we can see okay, this is a TLS server connection. We can see the on-request handler and so on. We can see how long did this request take and all this kind of information. Now we can look at it from the client perspective. So now I'm basically running the same thing, but now I'm collecting the data from the client. So now we can see that we got only the client requests here. Again, we can look at cool stuff. This one is in Node Core, so we can see it, but this one, we can see the callbacks registered. We can even see cool stuff like we can see the headers, right, that the client sent. Pretty useful, right? So let's say you have a problem, like you can even look at that. Like, oh, there's all these connections are open. Well, you can figure out what they are. And then you can combine that, obviously, because we can say, okay, we want to actually collect network and file system activity. So here's an example of a server. All it does is there's a request coming in, it reads the file, and then it just responds. So if we run that, then it looks like this. So we have the client request coming in, and then read the file. And you can easily see from here that the most time is spent reading the file, right? So that's where your bottleneck would be. And again, you have all this cool information. You can look at what's your file reinitiated, and so on. I mean, a wealth of information you can get from this. All right. So we're nearing towards the end here. If you're interested, here are some cool resources. So one illustrated blog post is really cool, and we have actually the author in the audience. So I highly recommend that. That blog post mostly speaks to the lifetime events that I just showed, but it's, has some nice pictures and so on. Kind of cool. Here is the Async Hooks documentation. That's in Node.js core. So that's like a huge document that you can read that has all the information about it. Even also, as I said, we only touched part of the API. So this one has other parts, the embedded API and so on included. You can get even further with that. And then, as I said, I started to work on this higher level modules, right? So they are all under node source. And if you actually go to our repo and you type AH-, I have a link here, you get this kind of thing. Mainly there are collectors and processors, right? So I wrote collectors for the file system and the network so far. It's all still under the, kind of under construction. I'm still working on this. Hoping that some of you may, find this interesting, may even help me fix some bugs. It's really well tested and documented, so it should be easy to jump in. And here we have the related processors. And then I highly recommend you to check out the Node platform that we built and installed at NodeSource. I'm really proud of this. We added some really cool features lately. So check that out. And that brings me to the end of the talk. Again, follow me on Twitter if you're interested. And ping me with anything you want. Or go to the repos and ask questions. I'm highly willing to help you out because I want to kind of get this ball rolling more. Thank you.